Exactly constitutes a solar system? Well, aside from the obvious requirement of a star, a solar system means more than just planets revolving around a big ball of hydrogen and helium. Anything influenced by the star's gravitational pull is part of the system, and this includes asteroids, comets, meteoroids, and other natural satellites. Estimated to be more than 4.5 billion years old, our Sun breathes life into our wider solar system. But while this corner of the universe is big enough to keep the likes of NASA busy for the foreseeable future, it is but one tiny part of a larger galaxy, the Milky Way. To us, there is only one solar system, as other clusters are referred to as stellar or star systems. But estimates suggest that there are approximately 200 billion stars in the Milky Way. Our galaxy's almost incomprehensible size puts things into perspective, but the Milky Way is also merely one small town. Modern estimates claim that there are upwards of 2 trillion galaxies total in the universe. So how exactly does all of that come together? If someone were to leave the solar system, would they soon encounter a new collection of planets orbiting another ball of fire? Eventually, possibly, but not before some serious voyaging. Collectively known as the interstellar medium, the space-separating star systems begin where the sun's magnetic field stops influencing its surroundings. It chiefly consists of gas and dust, because regardless of what it seems, space isn't truly a vacuum. The density varies widely from area to area, but none of it is ever truly empty. Again, in the grand scheme of things, the solar system is minuscule, and yet human ingenuity has yet to advance far enough to allow for a safe voyage into interstellar space. Due to the vast distances being calculated here, we use astronomical units to actually measure space, with 1 AU equivalent to the average gap between Earth and the Sun, which is approximately 93 million miles. Entering into only the first stretch of interstellar space means traveling farther than 120 astronomical units, and even then, the Sun's gravitational pull continues to wield some effect for roughly another 100,000 units. Given that humans have made it to the Moon and no further, with trips to other planets still seeming a far-off dream, getting people into interstellar space seems an impossible goal. However, while a manned shuttle isn't currently on the cards, 2 spacecraft have successfully crossed into the interstellar. Voyagers 1 and 2. Launched in 1977, Voyager 1 has been flying away from the Sun towards the great unknown for decades. After completing its primary mission by 1980, Way? Unsurprisingly, we're low on first-hand accounts. But the light from Proxima Centauri would always be in your sights, growing just that little bit brighter day by day. If humans ever were headed that way, then chances are they'd be beelining for the exoplanet Proxima Centauri b. It's the closest exoplanet to us, and it orbits within a potentially habitable zone. So if there is life outside the solar system, then it would be a good bet to host our closest neighbors. And from there, if we've advanced enough as a species to survive such a monumental trip, then the entire universe is ours to explore. Again, the Milky Way, housing us, Alpha Centauri, and billions of others, is simply one member in a gigantic universe of other galaxies. Andromeda is the next nearest similarly sized galaxy to ours. So if we ever could go galaxy gallivanting, then we'd wind up in Andromedaean territories next. Even Andromeda is estimated to be around 2.5 million light-years away from us, though. So we'll need light-speed travel to stand even a slim chance of seeing it. But this time, light-speed travel plus another ever-present concept in speculative thinking and far-future planning, the generation ship. Despite being among the fastest objects ever built by humanity, space shuttles are slow. They're not nearly powerful enough to truly explore the universe, or even the solar system. The harsh reality is that we may never be able to build the machines needed to practically send people to other planets. So if speed isn't the answer to interstellar travel, then what is? Another option is to travel at achievable speeds instead, but over a long period of time. The universe places a speed limit on matter, the speed of light. And that's a big problem for us because, given how massive space is, it means that most of the stars and planets out there are also out of our reach forever. If an astronaut-carrying ship were to travel to the next nearest star, Alpha Centauri, at speeds we're currently capable of for a ship of that size, then everyone on board would have died of old age, long before arriving. But, and here's the important part, if that original crew were to have children during the journey, then the next generation could keep on traveling, and so on, and so on. That's the idea behind a generation ship. A spaceship large enough to house a group of people that will live and die in transit. But by continually allowing future generations to take over, humanity as a whole could survive the long stretches of time needed to voyage across space. One day, we would make it to another distant star system. In theory, a generation ship makes interstellar travel to anywhere possible. In practice, it's arguably the best bet we have. These ships are a popular subject in science fiction because of this, but also for a few other reasons. For one, there's the feeling that they truly could one day be needed in real life, if any kind of catastrophe were to happen to us on Earth.